A few years after Copernicus's ideas about the sun being at the center of the cosmos were published, a young Galileo Galilei, a mathematician, was fascinated by the ideas that this might be a real issue, that he takes a side with Copernicus, but in order to do this, he realizes this is actually one small part of a much larger one, which is questioning whether Aristotle had been actually correct in the first place. Now, this was a very dangerous thing to do because much of the church's theology had been built upon an Aristotelian understanding of the cosmos. And so by bringing this in, he was challenging not just simply the ways in which we look at the planets moving around, but rather the ways in which we begin to start to take a look at all things with nature and the ways in which God interacts with nature. So Copernicus began a series of experiments that would test not only the accuracy and the possibilities of Copernicus's model, but also that would test the accuracy of Aristotle's foundational principles that Ptolemy had built on in the first place. So he starts a number of them, looking, for instance, well, if all of the heaviest objects pool at the center, Aristotle had said the heavy object needs to fall faster than the object that is lighter. And so he dropped objects from the top of the Tower of Pisa and measured and saw that they had landed at very, very close to the exact same time, suggesting that Aristotle's basic definition was not actually correct. Likewise, he looked through a telescope that he had made in order to observe these things, and he saw that there were moons surrounding the planets, particularly the planet of Jupiter. And by identifying these moons, this casts into doubt the idea of the crystalline spheres that is moving around the Earth and that the Earth is the center of the cosmos. The final thing that he looked at is he looked at comets. Comets, of course, had been known. They had been studied and observed. But everybody had assumed that the comets had taken place inside of the realm of the moon, where the realm of fire had not yet made everything perfect. And so the changeability of the comets was seen as being something fairly close to the planet Earth. But by looking at it through a telescope, he could see that the comet's orbits were actually going behind the moon, suggesting that the comets were further away than the moon. Again, denting and damaging the ideas that were developed originally by Aristotle and then by Ptolemy. So what he's giving is he's giving evidence in order to be able to add up to a full point in support of his issue to solve it as an ill-defined problem. And so he's a perfect example of all the different learning and problem-solving skills that are outlined in this particular chapter. He studied worked examples. Naturally, there were thousands of worked examples now because people had been observing the nighttime skies forever, but they had also studied he was able to look and see specifically the dropping of these particular items. He worked on a simpler version, looking at the moons around the planet as a microcosm of the overall cosmos was a way of breaking down this very difficult problem of all of the stars and all of the planets in the nighttime sky, and just instead looking at a very small version of them. He broke the problem into parts. He didn't just take an attack at Aristotle in one aspect. He looked at this aspect of Aristotle, this aspect of Aristotle, this aspect of Aristotle, and began to question each one of these simultaneously, ultimately to get to the idea of supporting Copernicus's model of the nighttime sky. He worked backwards. Really, if his whole purpose was really to prove that the Earth was not at the center of the cosmos, well, then he starts, though, with these other attacks on Aristotelian thought and on the primary foundations upon which the Ptolemaic model was built. He studied successively partial solutions, each one of these building up towards an overall critique of the Aristotelian worldview. And he solved analogous problems, right? Dropping these different dropping these different items to see how they fell, looking at the particular comets, right? This is, again, breaking down, finding little things that would be elemental and that would be able to be explanatory for the overall issue. And then the last thing is he creates an external representation of the problem. Now, Copernicus had already started to do this, drawing charts of the planetary motions as they went around the sun rather than around the Earth. So let's take a look now at this fourth and probably most important scene of constructivist learning and problem solving. First, note that we are coming to the full fruition of the learning. Like Copernicus, Galileo is taking multiple perspectives to come to his learning and his ideas. He is looking at the ancients, he is looking at Copernicus, he is actually engaged also in a discussion with other people like Tycho Brahe and Johannes Kepler, who I'll bring up in my 5th episode to try to talk about these. Galileo also models critical constructivism. He's recognizing the negative qualities of the structures that were built, and he seeks to deconstruct them even as he's constructing new learning in its place. This will eventually bring him into a conflict with the church and will create great problems for him for the rest of his life. And because of this, he needs to be thorough in taking on such a weighty and long-lived belief.